So we can see that that ultimately 2D CNNs have been applied to a lot of sound detections and classification problems, and they have been very good. They have very good results, and this is because they analyze the images and the frequencies, and this has demonstrated. For example, in the past, we saw that in the beginning of the presentation, we have like, for example, these classification studies that I mentioned that were like wheel species based on the whistles, and most of these classification studies have been recorded and have been used with images, and we are trying to improve them by using the same techniques that are used. Mostly, they have been used with 2D CNN or convolution neural networks approaches, and we're seeking to improve them in that way. Maybe it is a better approach for the occlusion of sound, as I mentioned, because maybe a multi-layer perceptron can have that very good results as the laboratory because of the sound or the noise that is detected in the environment. So that's why we are trying to use the 2D CNN to improve our models or our studies in these events.
Okay, excellent. Good luck with the future work. It's a very interesting application.
Thank you very much.
There is no question either in social networks. So if there is no more question, we can proceed with the next speaker. Thank you, Javier.
Thank you very much.
The next word is energy saving by using Internet of Things paradigm and machine learning. And I think the presenter is Josimar Reyes Campos. Are you there, Josimar?
Yeah. Thank you.
Okay. Please start when you are ready and sharing your presentation, please.
Well, good morning. My name is Josimar Reyes Campos, and I will be presenting energy saving by using Internet of Things paradigm and machine learning. And as a part of the introduction, right now I am going to review some concepts of interest. First, the Internet of Things consists of interconnected physical devices.
Josimar, can you stay close to your microphone because it sounds very low, very far.
Is it better?
Yeah, I think it's better. Thank you.
Well, first, the Internet of Things consists of interconnected physical devices and software components. These connected things or objects exchange information to provide a service to the end user. And currently, there are a large number of devices for daily use with the aforementioned interconnection capacity, such as smartphones, sensors, actuators, cameras, among others. IoT is considered within the domain of domotics application, which is concerned with the realization of intelligent home environment. Also known as home automation, domotic is a set of techniques aimed to achieve the automatic control of a home, considering security, energy management, welfare, or communication schemes. The application of domotic in the IoT faces certain challenges, such as the lack of platforms that allow communication between devices, the development and implementation of security protocols that protect the privacy of users, or the establishment of automatic configuration through smart schemes that analyze the tastes and usage history of the user. The machine learning is the study of methods for constructing and improving software systems by analyzing samples of their desired behavior rather than by directly programming them. Well, machine learning methods are appropriate in application settings where people are unable to provide precise specifications for desired program behavior. But where examples of these behaviors are available. The application of classification algorithms is very broad, as they can be used in areas ranging from economic and financial frameworks to health and safety services. Likewise, C45 has established itself as a reliable algorithm and whose performance can surpass other algorithms such as car or random forest. Well, for this project, the problem identified was that nowadays there are I'm sorry, that there are many applications that can control smart home devices. There are also more and more devices that can be connected to internet, and this has led the development of various research efforts focused on domotic and smart homes in the IoT paradigm. However, many of those efforts do not consider the historical analysis for automatic control of energy consumption for the benefit of the user. So this led us to a question of how to achieve energy saving through artificial intelligence-based techniques. And to answer this, platform called IntelliGuard was developed. This platform optimizes energy consumption through machine learning and IoT, allowing, among other things, to improve user comfort at home. And the proposed application makes use of machine learning algorithm C45, which allow predicting one or more discrete values based on attributes of a dataset. As the general objective of the project was to develop a smart platform that performs the energy control process in the field of home automation through wearable devices, machine learning, and the Internet of Things. Well, the architecture of IntelliGuard was proposed in order to achieve the general objective. And this architecture takes into account a physical domotic system, which includes the necessary communication technology for controlling and monitoring domotic devices. On this domotic system, the intelligent platform is implemented, and it's component by sensors that are devices used to detect changes in data values coming from the environment, actuators, which execute certain actions after receiving the commands to do so. There is also a web services set that contain methods to perform actions through a communication interface between the physical system and the mobile application. They allow collecting data from the sensors and for preparing and sending instructions to the actuators. There is an information acquisition and analysis module that stores, validates, and filters the information obtained from physical devices through the invocation of the web services. There is the sensor data reading submodule that consists of receiving data from the sensors, which is validated to ensure consistency and integrity, and finally redirecting it to the data mining submodule, which analyzes the information content of data and determines its usefulness and store historical records. There is a user control that represents the application to which the user has access, through which he can console the information either to control the devices or let the system take accounts for him, take decisions for him. There is an acquire information presentation model, which is a real-time monitor to present the information from the sensors. There is a historical information presentation model that aims to present the information previously processed and stored by the data mining model. The ordering and structured visualization of the data history allows users to keep track of the use they give to the system. There is an energy saving model that uses the machine learning algorithm C45 to generate the most suitable rules based on derived from the usage history of the devices. Once generated the rules, they are applied to automatically configure the devices with almost no human intervention. So in order to discover energy consumption patterns, it is necessary to obtain and analyze data related to the actions that the user executes in the IntelliGuard platform. When a user's history is available for each device, C45 uses the data to perform the configuration automatically. So the algorithm starts processing large sets of sensor readings that are examined to discover these behavioral patterns. These patterns are then expressed as models in the form of decision trees or sets of conditional rules, which are used to classify new readings. There is a automatic configuration model, is where the user can establish comfort settings according to their preference, considering the energy saving recommendations, and a manual control model that is responsible for providing the user with a friendly interface from which it's possible to issue direct orders to the actuators connected to the system. This model does not use prediction. Now, a case study is presented, which was carried on to validate IntelliGuard and consolidate it as a tool that reduces energy consumption without neglecting comfort in the house. The case study scenario was a home automation system integrated into a house, monitored to obtain data from the devices connected to it and to ensure that the system can provide efficient energy consumption and comfort to the residents. The system uses four types of sensors: temperature, presence, artificial, and natural light. And as shown in the figure, the real-time information of the house is obtained by the sensors, and every reading coming from them is accessed by the IntelliGuard through web services to analyze information and to automate the configuration settings of the devices. The user can interact with the IntelliGuard through an application installed on his mobile device. So as a case study, 4 houses located in Mexico were monitored. Each house was inhabited by 3 residents and had installed home automation devices to measure energy consumption. The characteristics of the houses were to make fair comparisons among similar environments and were monitored over 2 periods of 2 months each. During the first period, users were asked to interact normally with their home automation devices, controlling them manually using the mobile application. This period was used to obtain specific data on the energy consumption of the houses, as well as to obtain the values necessary to train the automatic configuration model. Once the classification models were obtained through the use of C45, it was possible to classify new data in such a way that IntelliGuard activated the home automation control rules necessary to improve the energy saving scheme and improve the houses. During the second bi-monthly period, residents were instructed to make use of IntelliGuard's smart configuration model and let the system control home automation devices in the most autonomous way possible. Information on energy consumption was also collected. And at the end of the period, the amounts established in the energy consumption receipts issued by the Commission of Mexico from the first and second period were compared, as well as the data obtained from the sensors during each period. So this confirmed that favorable results were obtained in terms of savings. Here are some screenshots of the mobile application developed as a control interface so that the user can interact with their devices. And here are some readings of the energy consumption of the devices of each house. This data was analyzed in order to discover the consumption patterns and create the decision trees appropriate to activate the energy saving mode. Here I present the resulting IntelliGuard workflow. So in order to obtain data that serve as a training set so that the predictive algorithm can automatically turn on the saving mode of the application, the energy consumption of each device in the house is obtained. Then the values are condensed and analyzed by the C45 algorithm in order to discover energy consumption patterns, which allow to determine the decision trees to be switching on the saving mode with the respective rules applicable to home automation devices. And well, here the graphic shows a comparison of the daily energy consumption made during the first 2 months against the consumption of the second 2 months. On top of each bar, you can see the final sum of periods, where saving of 144 kilowatts stands out for house 1, 89 kilowatts for house 2, 42 kilowatts for house 3, and 107 kilowatts for house 4. This table shows the Federal Electricity Commission fees taking into account for calculating the final results. And these are the corresponding amounts reached by Mr. 1 and by Mr. 2. And note that in the case of house 1, the reduction is about 26%. For house 2, 25%. House 3, 14%. And finally, house 4 is about 28%. Well, as part of the conclusions, it was identified that today energy saving is an issue with great importance due to its economic impact. Also, machine learning techniques in combination with IO allow the identification of energy consumption patterns, which can be used to define energy saving strategies. And IntelliGuard was able to reduce on average 23.25 the rates the rates of for energy consumption in the houses where the energy saving mode was activated. And finally, as future work, it is intended to incorporate IntelliGuard different configuration scenarios of automatic control, such as security scenarios and comfort. These scenarios will allow establishing the rules needed by the automatic configuration model for correct real-time decision making. In this way, the user can select the rules that best suit his needs, depending on the current situation. It is also intended to extend the number of devices that can be controlled by IntelliGuard. And finally, to consolidate the effectiveness of IntelliGuard, qualitative and quantitative evaluations are planned. These are some of the reference consulted for this project. And presentation. Thank you very much for your attention.
Thank you very much, Josimar. It seemed there is some problems with the sound because your voice was cut in some moments, but I hope that everyone have heard the main idea of the work and very interesting. I can read here a question from Roberto Gil. He says that, how can I apply in a bank? I think that he's questioning if there is possible to apply in a bank and what will be the benefits or what will be the way to apply your application or your model in a bank.
Well, in a bank, perhaps as I said, as the future work, not only it is intended to limit this project to the energy saving scheme, also, for example, for the security scenario. So the thing is that according to the sensors that are implemented in the system, it can be monitored some patterns from not only the people that work in the bank, but also the user, to trigger some rules that can be established previously in combination with these new readings in order to improve this security of the bank, or even, for example, maybe comfort. But the thing with the algorithm is that it can analyze the information, you can record the information, and then you can analyze it and construct the decision trees in order to be specific for cases from this scenario that is, how do you say, that he said. I'm sorry.
Okay. There is no more question at the moment. I have another question. When you test your application, you mentioned that you use 2 different periods of time. In the
Yes.
first period, the application was just reading the energy consumption, and in the second period, you activate your, let's say, saving mode of your application. Did you consider that perhaps there is some differences in the energy consumption depending of the season of the year? Because in the first period, yes, that's the slide, was in November to January. I think it's the more strong of the winter. And in the second period was from January to March, I guess. Perhaps there is some change of the behaviors of the inhabitants of the house, changes, depending of the season of the year. This is more close to spring, and the other was in the winter. Did you consider that perhaps some difference could be also because the season of the year? I don't know if the people inside of the house use more lights or caleffaction or something like that. Have you considered to test your application in reading mode and in saving energy mode during the same season of the year, during the same period, in a house with similar characteristics, but in the same period?
Yes, it was considered. The readings are, well, the system is always reading the data from the sensors, from the devices, because it is true. For example, the use of air conditioning or other devices are tend to be higher, and that's why it should be always be recorded these readings in order to analyze in every time of the year the patterns of the users to be able to establish the configuration rules.
Okay, so this configuration is dynamic according to the readings from the sensors.
Yeah.
Okay. Thank you very much, Josimar. Let's check if there is no other question. Then we can proceed with the next work. And the next work is titled Plant Leaf Disease Recognition Using Random Forest, KNN, SVM, and CNN. And the author is Vijaya Hatuwal. Are you there, Vijaya?
Yes, I am.
Okay, then share your screen and please start when you are ready.
Is my slide visible?
Yes, it looks well.
So my name is Vijay Kumar Atwa, and I will be presenting on plant leaf disease recognition using random forest, KNN, SPM, and CNN. So plant that suffer from different infectious diseases, maybe due to the environmental condition or bacterial infection. And due to these infections, there is a huge loss in the crop production each year in the developing countries like Nepal, Bangladesh. So that's a huge impact in the economic development and the GDP production because they are highly dependent on the agriculture. And the lack of the related field expert and their availability is quite unaffordable to the local people. So as a traditional approach, farmers, they make bare eye predictions. So most of the time they tend to be incorrect and lead to the incorrect procedure to find the correct cure. So the main objective of this study is to identify the healthy and disease image species of various plants. And we will develop various machine learning models like support vector machine, k-nearest neighbor, random forest, and convolution neural network to predict these diseases. And we will also compare the various models based on their accuracy to define which one is best for the task. So in the paper we have considered, which are related to our works, we found that they have considered quite a few species and the disease for their work, for the training and the prediction purposes. And in the CNN, most of them have considered different phases of the disease, like late blight, early blight, such kind of phenomena. And in the algorithms, they have incorporated very few features for the training and the prediction purpose. And most of the paper, they are either using SPM, KNN, or CNN only, and few of them have made comparison with one or two of the algorithms. And the accuracy they have obtained is quite comparatively low. So this is our finding from the previous related papers. And the methodology we have followed is like data acquisitions, image features extraction, and model training and validation, and finally the image prediction. So this is the general flow we have considered, like image data load for pre-processing, and image feature extraction like contrast, entropy, and correlation. And we'll be saving those in the CSV file format, and then we will be training the model like KNN, CNN as per the requirement, and we will load the stored extracted features previously and prepare the model. And we will go with the training, and we will tune the parameters again and again, so until we get the desired output, and finally we will save the model and will be used for the further prediction in the future. So in the data acquisition, we have achieved our data from the plant village data set, and we have considered 16 different image categories as healthy and disease. And in each category, there will be around 2,000 to 2,600 data. And the data obtained, they are split into 80-20 ratio for the training and the testing purposes in a separate file format. But for the like SPM, KNN, and random forest, we will be considering consolidate all the images into one folder and consider extracting those features. So in the feature extraction portion, we will be extracting 10 different kinds of features for training purpose. So we will be considering the mean and standard deviation of the each RBG color channel. And we will also gonna extract the contrast, correlation, entropy, and inverse difference moment of each image using the Haralick texture algorithm, which is uses gray co-occurrence matrix. So those files will be saved in the CSV file format, and before applying the Haralick texture algorithm, we will be applying the Gaussian blurring so as to remove any kind of image noise. So in the texture, what it actually means is the variation in the intensity of the surface, quantifying properties such as smoothness, coarseness, and the regularity of the image. And the entropy, it measures the randomness or the disorder of the image, and it achieves its largest value when all the elements in the co-occurrence matrix value are equal. So when the image is not textually uniform, many GLCM elements have very small values, which is imply that the entropy is very large. Therefore, the entropy is inversely proportional to the GLCM energy. And the contrast feature, it's the feature measuring the image amount of the local variation present in an image, and the inverse different moments, it measures the image homogeneity. This parameter achieves the largest value when the most of the occurrences in the gray level coherence matrix are concentrated near the main diagonal. And the final, the correlation feature, it's the linear dependency of the gray level values in the coherence matrix. So these four features, mainly the entropy, contrast, inverse difference moments, and correlation will be extracted using the Haralick texture algorithm, and others will be extracted by the channel value separation. Yeah. And for the extracted value from the earlier saved folder file, we will be separating the values as 80-20 for training and the validation purpose. And for the support vector meshing, we will be using the one versus rest method for the multi-class classification purpose, and the radial bias function for the radius calculation for the equation. So here xi and xj are the input features value, features in the input space, feature space. So the regularization parameters C was tuned to 100 and gamma to 10 to the power minus 3 and tolerance to 10 to the power minus 3. This value was achieved by the manual tuning. So earlier we applied for using the grid source once, but changing the categories we couldn't apply it was as it was taking longer time. So we did manually from there and achieve this value to obtain the best result for our task. So our next algorithm is k-nearest neighbor. So it's a non-parametric method used for the classification and regression. And for the multi-class classification purpose, we use the Hamming distance. And it's the distance between the 2 points, absolute distance between the 2 points. So for this KNN to find the best optimal value, we have plotted the elbow criterion plot, which is the iterative process for the given range of values. It will iterate and find the result for each iteration. So another algorithm used was the random forest. So it is the ensemble method, which uses the average of voting from the multiple uh, 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 multiple estimators. So we have for this task we have considered 250 estimators. So this was also fine-tuned using the manual process. So it was quite a repetitive task to do manually. And this problem of overfitting was drastically reduced. Consider the other models. And another one is the convolution neural network. So this model directly fed upon the images we have considered as training and validation. So 4 different hidden layers for this model was considered, and the image of size 800 and 800 by 800 pixel value was used. And the convolution kernel matrix of 3 by 3 and the maximum pool matrix of 2 by 2 was applied. And the rectified linear unit was used as an activation function, and dropout of 0.5 was added. And the same activation function was applied to the connected layer with the dense value 16, as we are going to create for 16 different classes. And before applying the training to the data, we have also considered augmenting the data to reduce the training overfitting. So we have applied the horizontal and vertical flip, and also we have applied 0.2 CR values. So the result looks something like this, and KNN performed value for the accuracy for KNN was obtained 76.96. So this is the elbow criterion plot. As you can see, it has obtained the best accuracy at voting when there is k is equals to 1. But due to the outlier in the possible prediction values, so we have considered 5 k is equals to 5, so that there will be a proper voting and will not be considering any kind of outlier. So if you consider 1, it will be giving us the best values prediction for this model, almost about 87%, but we will not be considering that. So, and these are the weighted precision values for the model. So it is 0.78, 0.77, and 0.77 for all. And this is the heat map plot we have developed for this truth and predicted values. So it's a quite large class. So we have considered using the numbers only. And another model, our SPM model, was predicted with an accuracy of 78.61%. And the random forest achieved the accuracy of 87.436% with the 250 estimators. And this is the simple output. This is the output we have obtained as a user interface. We have obtained, and this is the user interface, and we can show the different channel levels for the image we have considered. So the convolution neural network was able to achieve the training accuracy of 97.89 and the validation accuracy of 99.01. And 147 epochs with 29,561 images and 7,391 images for the validation were used. And the model was trained in the Google Colab device named GPU0. So this is the plot for the model accuracy and model loss for the training and the testing purpose. So as a conclusion, we have considered different 16 categories, which is quite a lot category considering the other papers, and 10 different features like red, green, and blue channel, standard and mean, and early texture features like contrast, entropy, inverse difference movements, and correlation were considered. So they were fed open to the random forest, SPM, and KNN to perform the training and validation. And among the used model, CNN was able to produce the best value based on the accuracy. So it was able to achieve the accuracy of 99.01 for the validation, and random forest was 87.43%, similarly followed by support vector machine and k-nearest neighbor 78 and 76%. So in the future, we are considering using multiple plant specific species and diseases, and improvement in the given model's prediction can be done by incorporating much distinct features like uh, uh, some variance, average second moments from the architecture. So that can be included to increase the number of the features and make much more precise prediction with less number of images. And the grid search or other algorithms can be used to find the best optimal value of the hyperparameters used for the different models. So we have considering use grid source methods once, but it was taking quite a long time. So for the second approach, we just applied the manual tuning. So considering a much better approach like grid search or others can be applied in the future.
Okay. Thank you very much, Vijaya, for the presentation of your work. If somebody have questions, please write chat. No question at the moment. I have two questions, Vijaya. The first one is the data that you used for the training, the image that you collect, it was taken in a natural environment. I mean, the leaf is on the tree or in the plant in a natural environment, or you cut the leaves and then you take the picture in a controlled environment in your laboratory. This is the first question. And the second one is how did you label the two classes, that the healthy leaf and the leaf with the disease? It was manually. You distinguish the two classes, and or you label it in a manual way, or how did you label to distinguish the two kind of leaves?
Yeah, thank you for the question. And yeah, so collecting the image in our tasks, we obtained it from the plant village dataset. So it wasn't a difficult task for us. So we could obtain quite a huge amount of data there. But in the real life, what we do is we just click one of the images, like what we want to classify, like maybe 200 to or 300 samples of images for the support vector machine, random forest or KNN. So except for the CNN, it would be required much less of the data to actually predict. So that would be much faster and easier way to classify and predict the data in a real time. So if you are considering for the higher accuracy and with the higher amount of volume of data, so you will be, it's better to go for the convolution network or some kind of supervised learning kind of model. And for the labeling of the data, yeah, we obtained the data from the plant village dataset, so it wasn't a really tedious task for us. But we have also considered other dataset like coffee in our earlier work. So that was really a tedious kind of work in the whole task. So what we did, it was quite taking a lot of tasks for us in the whole process. So in that time, what we did was there was Excel file in which we considered the type of the data, there what's the value or the label the coffee data set was obtained. So what we wrote a script that will load the data into the MS SQL server, and we use a Python script to manually label the data, so automatically label the data and classify according to their folder. So that was the most efficient way I could find, and it would be really helpful. So if you go into the field, you would just take a picture and consider the name and write into somewhere Excel or in the file itself. So in the future, you can arrange accordingly, writing simple script. So it won't take much time if you consider that way. So I did, that was the approach I did.
Okay, thank you very much. There's one question from Larissa Janet. She said, how many features were originally extracted, and did you use a reduction algorithm?
So sorry, I didn't get the last part.
There is two questions. The first one is, how many features were originally extracted? And the second is, did you use a reduction algorithm?
So earlier in the there were considered like we only consider the architecture algorithm, but we also try considering the different image channels, so it would perform better, because in the when the digits bank they get the digits, some kind of color they might be getting changed, right? So if you consider the combination of the colors, so it would be performing much better. So we found out that like it an identical kind of process, so we considered using that. So it was easier for us. So the second part, I didn't really get what that means. So I mean, it's a kind of normalization process, or so it's a reduction kind of question, right? I didn't catch that part. So yeah, we applied the reduction for the random forest part. So it was really performing well when you consider the reduction kind of feature reduction. So it was performing well in that part. So compared to the others like SBM and KNN, random forest was performing quite well. So when we used the reduction kind of feature, reduction in the features.
Okay, I think there were some problems with the sound. She insists that the direct question is how many features you originally extracted the number. You have it?
Yes, if I may ask directly, I just want to know how many features, how many variables did you extract from each leaf to do the whole procedure?
Yeah, so for the KNN and support vector machine and the random forest, we extracted 10 different image features. So that would be the mean standard deviation for the each color channel. So it would be 6. And another is entropy and inverse different moments, contrast and correlation. So in total, there are 10 different features we have considered. So
10.
for
Did you say 10?
Yeah. So for the convolution
Okay.
neural network, it won't be extracting any features. So we'll be directly feeding upon the image.
Okay, thank you very much. Excellent work. Congratulations.
Thank you.
Okay, thank you very much, Vijaya. And then let's move to the last presentation. And the work is lemmatization method with extra trace technique test on language from different language groups. Is Iskander Akhmetov here, or Irina Ulyayeva, or Alexander Park? Is anybody here from this work? Because we don't have a video presentation either. So I guess there is no last presentation. No? Okay. Then thank you very much to everyone to attend this machine learning 4 session. We had 4 excellent works. To all the presenters, you will receive your certificates of attendance by email during the day or the following days. And then we say we have to close the session if there is no more questions or more comments. In any case, you can read the email addresses of all the presenters in the proceedings. If you have any further question, you can contact directly to the authors. Then thank you everybody for coming, and please go attend to the other session of the last of MICAI 2020. Thank you very much, and see you everybody.